everyone, and welcome back to the channel. Today, we're going to have some fun with one of the simplest toys around, a balloon. But we're not just making decorations. We're going to unlock the amazing science hidden inside these colorful, stretchy spheres. Get ready for 5 mind-blowing experiments you can do right now with just a few household items. Let's get started. First up, the classic static electricity trick, but with a twist. You've probably rubbed a balloon on your hair to make it stick to a wall. That's static electricity. But did you know you can use that same power to bend water? Blow up a balloon, rub it vigorously on your hair or a wool sweater for about 10 seconds. Now, turn on your faucet to a thin, steady stream. Slowly bring the balloon close to the water, but don't let it touch. Watch in amazement as the stream of water magically bends towards the balloon. This happens because rubbing the balloon gives it a negative charge, and water molecules, which have a positive side, are attracted to it. It's like a tiny, invisible tractor beam. How cool is that? For our next experiment, we're going to test the limits of a balloon with fire. Sounds dangerous, but trust me, it's all about the science. You'll need 2 balloons, a candle, and some water. First, blow up one balloon with just air and tie it off. Carefully hold it over the lit candle. Pop! It bursts almost instantly. The heat from the flame weakens the rubber, and it can't handle the pressure. Now, let's try it again. Take the second balloon, and before you blow it up, pour a little bit of water inside, maybe about a quarter full. Then, inflate it the rest of the way with air and tie it. Now, hold this water-filled balloon over the flame. What do you see? It doesn't pop. The water inside is a fantastic heat absorber. It soaks up all the heat from the flame, keeping the rubber cool enough to stay intact. The water is protecting the balloon. Ready for some chemistry? Let's make a self-inflating balloon. For this, you'll need a balloon, an empty plastic bottle, some baking soda, and vinegar. First, pour about an inch of vinegar into the bottle. Next, using a funnel if you have one, carefully add 2 teaspoons of baking soda into the deflated balloon. Now, stretch the opening of the balloon over the mouth of the bottle, making sure not to spill any of the baking soda inside just yet. When you're ready, lift the balloon up and let the baking soda fall into the vinegar. Fizz bubble, and watch as your balloon magically inflates all by itself. What's happening? The baking soda and vinegar are having a chemical reaction that produces carbon dioxide gas. This gas needs space, so it rushes up and fills the balloon. Science is basically magic. You can explain. Next, we're going to build a super simple hover. You'll need a balloon, an old CD or DVD, and a pop-top lid from a water bottle or dish soap. Glue the pop-top lid desafio o desenterrado. Decida right over the hole and make sure the seal is airtight. Let the glue dry completely. Once it's dry, close the pop-top, blow up your balloon criterios, and pinch the neck to keep the air from escaping. Carefully stretch the neck of the balloon over the pop. Now, place your CD hovercraft on a smooth, flat surface like a table or a tile floor. Open the pop-top and give it a gentle push. It glides. The air escaping from the balloon creates a cushion of air underneath the CD, lifting it up and reducing friction to almost 0. This is the same principle that real hovercrafts and even air hockey tables use. For a final experiment, let's see if we can pierce a balloon without popping it. It sounds impossible, but all you need is a balloon, a wooden skewer, and a little bit of vegetable oil. Blow up the balloon, but not too tight. Leave it a little squishy. Now, look at the balloon. You'll see a darker, thicker spot at the very top, opposite the knot. This is our target. Dip the sharp tip of your skewer in a little oil to lubricate it. Now, with a steady hand, gently but firmly push and twist the skewer through that thick spot at the top. Keep pushing until it goes all the way through and comes out the other thick spot near the knot. Ta-da! A skewer right through a balloon, and no pop. The rubber at the top and bottom of the balloon is under the least amount of tension, so the long polymer chains can stretch and seal around the skewer instead of tearing. And there you have it. 5 incredible balloon experiments that prove science is all around us, even in the simplest of toys. Which one was your favorite? Let me know down in the comments. Try these at home, always with a grown-up supervision, and have fun exploring. Thanks for watching, and don't forget to like and subscribe for more awesome science adventures. See you next time.